guys, we're continuing our work on inequalities, and here are a few examples of real-life inequalities. So what we're going to do is write an inequality for each of these situations, and then write 4 numbers that are in the solutions and 2 numbers that are not in the solution set. Okay, so here we have a parking sign, and it says 20 minutes. So let's write an inequality. We'll pick a variable P, and we'll write 20. Okay, so can we park for 20 minutes? Sure. So let's draw a line for the equal sign. So then the question becomes, can we park for more than 20 minutes or less than 20 minutes? So I believe if you park for more than 20 minutes, you'll get a ticket. We don't want that. So we need to put P is less than or equal to 20. So then the solution set would be 20 and any numbers greater than 20. 25, that's wrong, less than 20. So we could do 20 minutes, 19 minutes, 17 minutes, or even 5 minutes we could park, okay? But we'd have a problem if we parked for 21 minutes or even 25 minutes, okay? Let's look at the next parking sign. Handicap parking, a minimum of $250 if you are not handicapped and you park there. So, okay? So then what we do is we write P and we write 250. So can they charge you $250? Well, sure. But that's the minimum. So the actual fine can be greater than or equal to 250. Okay, so now what does that solution set look like? And we'll put it up here. So that means that they can charge you $250, they can charge you $500, or they could charge you $1,000. Okay, there is no maximum, which is scary, right? Okay. So what is not in the solution set? Well, for less than or equal to 250, what's not there would be $199 or $100 or any number less than 250, okay? And that goes in infinity or beyond, okay? All right, that's a little Buzz Lightyear for you. Okay, so let's look at the next one. Los Angeles minimum wage, which in Los Angeles would be not a lot of money. So our hourly wage is $10.50. So we're going to put, so yeah, sure, we can make $10.50 an hour. So we put the line for equal, but can we make more? Sure. So we're going to put our hourly wage is greater than or equal to $10.50. All right, so what numbers are in the solution set? It would be $10.50. It could be $10.60. Woohoo, 10-cent raise, right? Or you could be in the big leagues and make $20 an hour. And even better for some of my very good math students, $50 an hour, right? Okay. But what they cannot pay you is what? $9 an hour? $8 an hour? Okay. Those numbers are not in the solution set. And if you were working, someone tried to pay you that would be called illegal. Okay, let's go to the next one. Baggage, Air Canada. And we were discussing in class, Air Canada uses the metric system. So they probably wouldn't have inches and pounds. They would have centimeters and kilometers. But at any rate, when you go on the plane, your baggage can't go over a certain weight. In this case, it's 22. So let's put B for our inequality. And can your bag weigh 22 pounds? Well, sure, you're right there, but it can't weigh more than that. So B has to be less than or equal to 22 pounds. So in our solution set, our baggage can weigh 22 pounds. Our baggage can weigh 21.8 pounds. Our baggage can weigh 5 pounds. Our baggage can weigh 3 pounds. And that would never be my bag. Okay, but if our baggage goes over, and let's just put 23. If you go to the airport and your baggage is 23 pounds, they're going to hand it back to you. Here you go. Take something out. Okay, that's happened to me. and it can't weigh 24 pounds. Let's turn the page. Next page, guys. All right. So we have been working on linear equations. And of course, an equation has an equal sign and one correct solution equation. So for example, the answer could be b equals 4. B is 4. That's an equation. But the great thing about an inequality is that there are multiple, an infinite number of solutions, okay? So for b is greater than or equal to 4, our answer could be 4, 5, 6, 7, 8, 9, and so forth, okay? The solution of an inequality is any value of the variable that makes the inequality true. So in the solution set, any value of the variable that makes it true, okay? So let's look at the next one. Which of the following numbers are solutions of the inequality b is greater than negative 4? So the first thing I want us to do is write this out. B is greater, oh, my writing is atrocious, greater than or equal to negative 4. All right, then let's graph it. Because when we graph it, it helps us to make sure that we're selecting the correct solutions. So what numbers are to the right of negative 4? And I hope we're not saying negative 5. It would be negative 3, negative 2, negative 1, and 0. Right is greater. To the left of negative 4 would be negative 5 and negative 6. And remember, greater than or equal to is a filled-in circle. And our line is going to go in the same direction as our arrow. And greater than or equal to. Look at that. Here, we're going to pull this out. Hey, come on. Isn't that handy? Okay, so which of the following numbers are solutions of the inequality? Is negative 8 greater than or equal to negative 4? Well, negative 8 is to the left, so that would be less than. No. Is negative 3.5 greater than or equal to negative 4? Well, let's go over to our handy-dandy number line. And negative 3.5 is halfway between negative 4 and negative 3, which is in our solution set. Circle. Is negative 4 greater than or equal to negative 4? I believe so. And negative 4.5, is that greater than or equal to negative 4? Well, negative 4.5 happens to be to the left, which is less than, and that would be no. And then let's, in case you don't have this, I'm going to move it over. The last solution is 0, okay? And we're going to circle 0. All right, let's go down. Thanks. The next one, it says, now all we're going to do is graph, which was in the previous video. Inequalities are true for many values of the variable. So they are usually many solutions in the list. Therefore, we often illustrate the solutions in a graph. Okay, so let's go ahead and write an equation here. Some variable x, or whatever you'd like to select, is in the open circle, means greater than or less than. And when we go to the right, it's greater than. So all values of x that are greater than 3 are in our solution set. It does not include 3. Everything bigger than 3. So for example, at Chuck E. Cheese, to go in the bounce house, you have to be greater than 3. If you're 3, don't roll up there, right? Okay, let's, let's do the next one. Y. And we have a closed-in circle, and that's going to be left is less than, and our arrow is going to the left, less than or equal to negative 5. So if it's negative 5 degrees, guess what? We still have to go to school. But if it gets colder, like negative 6, negative 7, negative 8, then we get that phone call in the morning. No school, right? Okay, so anywho. Let me show you the remainder of the packet. Well, I will put the packet on Google Classroom, and you can finish it if you happen to not be here. Toodles.